We are on the COM tab here, and we're looking at the permutation and the combination equations. So let me zoom in here, get a little bit better view. Now the permutation looks at one group of objects with several ways of doing the same thing. So the example I'm giving you is you have 4 buttons to push. How many different ways can 3 be pressed? You have a total number of items, which is going to be n, and the number of selected. So in this case we have 4 buttons and only 3 can be pressed. So 4 and 3 respectively. Now I'm going to go to the Formulas tab and Insert Function. I already have it all right up, but let's just type it in, searching for it. So it's going to be the permute. And I'm going to enter in the actual cell. That way we can play with it a little bit to see what's going on. We can see an answer already, 24. So there are 24 possible ways of having 4 buttons and pressing 3. So what happens when we have 5, we go up to 6, let's change that to 4, all of a sudden 120. So depending on the number of combinations, it can go up very, very quickly. 2 limits it considerably. 1, there's only going to be 5. And what if we put 5? Well, 120. And that one doesn't work. All right, so you get the idea. The next set is the combination. And basically with the combination, you're looking at 2 groups. So the example I'm given is you have 3 types of paint and 2 rooms, where only 1 color per room. How many combinations? So 3 types of paint, 2 rooms. The answer is going to be equal sign combin down here. And let's go ahead and click on the cells. Close the parenthesis down here. And we push enter. Gives us a total of 3. So we say, well, that's not a lot of options. What will really increase my number? Well, let's increase the number of colors. Well, that did quite a bit. What about 5? Okay. What happens if we increase the number of rooms? That didn't help a whole lot. In fact, that's not really helping a lot at all. So rooms, not so much, but let's do 6. 7. Now we start increasing. Going back to just the 3, not a lot of options. These 2 formulas are particularly good when we're trying to figure out, well, how many different combinations do we have? How many different options can there be given a certain scenario? For example, how many different ways can we rearrange people within an office? How many ways can we rearrange machinery? How many colors are needed to get a certain number given certain constraints? All sorts of things can be used with the permutation and combination equations, all of which start leading up to the next section, which is probability distributions, which will be the next series of videos.